Hello class, this is Mr. Benson and I'm going to go over a couple of things on the 7.2 old class notes for day 2. I found that looking at the old class notes is really helpful because they're like what Mr. Whitehill puts on the board and they're already marked up. So you may want to use these to enhance the notes in your 7.2 packet. Today we're going to talk about increasing and decreasing, and we can see our graph here, and Mr. Whitehill has already drawn dots for increasing and decreasing, but in our graph here we have 1, 2 maximums and 1, 2 minimums. And so to review from the other day, this polynomial would have an x to the first, second, third, fourth, fifth. X to the fifth because we have 4 humps plus one more exponent would be x to the fifth. It's an odd exponent, so we have them going in different directions. This is ending going upwards. So let's talk about intervals that are increasing. An interval is a section or segment of the graph that is going upwards. So although this arrow down here is pointing downwards towards negative infinity, the graph as we move from left to right, because we read graphs like we read words from left to right, is actually going upwards. So between A and B the graph is increasing. Then it turns, and between B and C, but actually B and D, it's going down. And then here at D it starts turning up again. We've labeled the increasing in purple. It goes up until it hits about point F, and then it turns again to go downwards in a decreasing or green till it hits H, and then it goes up again. So the question asks, how many intervals are increasing? Well, there's 1 purple going up, 2 purples going up, 3 purples going up. So in purple, the number of intervals that are increasing is 3. And then we're asked to name them. When we name them, we're going to name them with parentheses. So we're increasing from A to B, so we're going to label that negative infinity all the way to B. And then the next point where it turns up is from D, it looks like, to F. And the final place where it's increasing or turning up in purple looks like it goes from H, and it keeps going forever in a positive direction. So we're going to call that from H to positive infinity. Now let's look at where the graph is decreasing. How many intervals is it going downward? I see one here from B to D, and another one here from F to H. So it decreases for 2 intervals. And then what are the names of those intervals? Well, it looks like again D to B to D. And then the other one is from F to H. Next I want to look at a problem from day 2. And today we're going to look at problem number 2. Question number 2. There are some true and false statements I want to go over with you. The first question is, the function is increasing at point A. Well, let's think about this. Although this arrow is pointing up, we read graphs from left to right. So from the left to the right, the graph is actually going downward towards A. And it keeps going down until it hits the low point, or the minimum, or the local minimum B. So the function is increasing at A? No, it's going downward, so this is false. Question number 2. At point C, it's a local max. Now it's not the maximum because we see that it rises forever here, infinity, but locally within this area, it is a maximum, so that answer is true. Point B is a local max. No, we see that b is part of the bottom of a dip, and we learned before break that that would be called a minimum, so that's false. Function is decreasing at d. Yes, it keeps going down at d, so that's true. Point A is a 0. Ooh, tough question. Zeros are where the line crosses the x line, and we don't see where it crosses the x line here. We know it will eventually after d, but where A hits the x, it is not at a 0. Zeros are not y crosses, but they're x crosses, so this is false. Is the function even? Remember, we learned that even functions end in the same direction. So they either end up or they end down. This one starts one direction and ends the other, so it's an odd function, so that's false. The other way to tell is if there's two humps or dips, and this has two, then it's to the exponent of one more than the number of humps and dips. So if this has 2, then this function is to the third, and 3 is an odd number. Odd numbers end in opposite directions. So again, that's false. The last question is answered for you false, but I want to talk about why. When the graph ends, or on the right, is going down, the lead coefficient, the number in front of that x to the third, is going to be negative. When the number in front of that x to the third is positive, it's going to end by going up.